I welcome all of you to the class. So, as far as this class is concerned, this is our lecture 2. So, today we are in lecture 2 of the course Numerical Techniques. And in the previous class, we had started finding the roots of nonlinear equations and using bisection method or the Bolzano's method. So, we are studying the bisection method. Fine. So let me divide my board into two parts. Fine. And the problem that we had in hand last time, we had a function of x, f of x is equal x cube minus x minus 4. This was the function equal to 0. We had to find one of the roots of this equation. So the method that we used is the bisection method. And in the bisection method, we had started with iteration 1. We had started with iteration 1. So we had started with the first iteration. It was iteration number 1. In case of iteration number 1, we had assumed x1 equal 1.5 and x2 equal 2. These were two assumed roots. We say let we start with x1 and x2 be the roots of the given function f of x is equal to x cube minus x minus 4 equal to 0. So this is our assumed values. But we had stated previously that these assumed values, selection of assumed values is entirely the choice of the solver. The solver is supposed to solve the assumed values, but an important condition is to be satisfied. The condition that these assumed values should satisfy is f of x1 and f of x2. That is, when we substitute the values of x1 and x2 back in this equation, should have opposite signs. This is what we had decided. We had discussed last time graphically. Should have opposite signs. Should have opposite signs, we can mathematically also write that when f of x1 is positive, f of x2 has to be negative. Or when f of x1 is negative, f of x2 has to be positive. Okay. So when f of x1 is negative, when your f of x1 happens to be negative, when this is negative, then f of x2 is positive. So if you look at the product of f of x1 and f of x2, you have f of x1 multiplied by f of x2 is equal, minus and plus is negative, it means it's less than 0. Fine. And when f of x1 is positive and f of x2 is negative, so the product is again negative. So f of x1 multiplied by f of x2 is less than 0. That is, it's negative in sign. This is an important condition for the bisection method. That is, we have to select this x1 and x2 in such a way that once you substitute the value of x1 and x2 back into this equation f of x, the product of f of x1 and f of x2 should be less than 0. And we can easily verify it here. For iteration 1, we can write f of x1 is equal, f of x1 will be 1.5 cube. It's 1.5 cube minus 1.5 minus 4. And that comes out equal to minus 2.125. Fine. And if you write f of x2 is equal, x2 is 2, so it will be 2 cube minus 2 minus 4. That is equal, f of 2 comes out equal 2. So this is 8 minus 6. Yes, that is 2. And if you look at f of x1 and f of x2, f of x1 multiplied by f of x2, that is equal minus 2.125 multiplied by 2. So this product is less than 0 because the product is negative. Therefore, the choice of x1 and x2 is correct mathematically. We write this is feasible. Okay, this is feasible. F of x1 and f of x2 product is less than 0. Therefore, the choice of x1 and x2 is feasible. Now, we will go to the next root of x. Okay, so I said x3. So once you have obtained x1 and x2, then we have to find the value of x3. And in bisection method, x3 is equal x1 plus x2 divided by 2. Okay, that's equal, your x1 is equal 1.5. That's equal to 1.5 plus x2, that is 2 divided by 2. Therefore, our x3 becomes equal, our x3 comes out equal 1.75. Fine. So this is our third value. We started with x1 and x2. Now from the value of x1 and x2, satisfying f of x1 into f of x2 is less than 0, we obtain the value of x3. Now find the value of f of x3. Find the value of f of x3. F of x3 is equal 1.75 cube minus 1.75 minus 4. Okay, when we say f of x3, you have to substitute the value of x3 back into your previous equation, that is back in this equation. So f of x3 comes out equal 1.75 cube minus 1.75 minus 4, that is minus 0.3906. Okay, so this is the value of our f of x3. The value of our f of x3 is equal to how much? The value of our f of x3 is equal minus 0.3906. Now we will see what we have to do. Once we have obtained the value of f of x3, we have to see where this f of x3 lies. Look, your f of x1, let me rub this portion. F of x1. Your f of x1 is, your f of x1 is negative. Your f of x2 is positive. And your f of x3 is again negative. When your x1 is, the value of our x1 is 1.5. The value of our x2 is 2. And the value of our x3 is 1.75. This is how it goes. Okay. Now we have taken f of x3. Okay. F of x3 is negative, and the value of x3 is 1.75. Now look here. You have to take the functions in such a way. You have to take the next iteration values. Okay. Now we said in the previous class, the functions that we had plotted graphically were like this. I said in the previous class that the functions that we are plotting are essentially like this. For example, the graph of the function is like this. Okay, we started with two values. This is x1, and this is the value of f of x1. And we assume this to be our x2. And let's suppose this value, this is our f of x2. Okay, because our f of x2 is positive and our f of x1 is negative. Our f of x1 is negative here and f of x2 is positive. Okay, fine. Now we are getting the third value. Fine. We are getting the third value of x3 such that we are getting the third value of x3. By the way, our x1 is 1.5. Our x2 is equal to 2. And we are getting the third value, that is x3. And our x3 is equal to how much? 1.75. So it lies between x1 and x2 in such a way such that f of x3 is positive. Oh, sorry, f of x3 is negative. Okay, because f of x3 is negative here. It's negative. Fine. So it means x3 is in at that very point of x-axis such that f of x3 is negative. So this point is the solution point for us. I'm repeating, this point is the solution at which our f of x is equal to 0. This is our solution point xs, which we have to find. Our x1 is here, our x2 is here. Fine. Our x3 lies between x1 and x2 in such a way such that f of x3 is negative. It means in between xs and x1, f of x3 has to be somewhere here. X3 has to be somewhere here. Why x3 has to be here? Because at this value of x3, our f of x3 is negative. If we say no, x3 lies here, say for example between xs and x2, if we say no, x3 lies here, then at this value of x3, the value of our function is positive, which is not the case, which cannot be the case, because the value of our x3, f of x3 is negative. It means f of x3 lies between x1 and xs. So somewhere here, we say x3 is somewhere here. Now, we have x3 here. Now we have to take the next iteration values. Fine. Which iteration values we will take? That is very, very important. So for the next, in the first iteration, our x1 was here. For the first iteration, our x1 was here. Okay. Let me write it with some other color. Our x1 was here and our x2 was here. Fine. And once we concluded the first iteration, we got x3, that is here. Fine. Now, our solution, the iteration point x3 is somewhere here. Okay, so first interval was x1 and x2. Now we have x3. Their values, the next iteration value we will take will be from x3 to x2. This is very important, which I was explaining you last time. That is, you have to bring this x3 very close to xs, and you have to bring this x2 very close to xs. Now you started with x1 and x2. From x1 and x2, you got x3. Fine. Now x3 is somewhere here. Now what we will go, we have to find the next interval. Our next search interval will be from x3 to x2. Okay, that is our next search interval. I will begin with the next iteration. The next iteration will be iteration number 2. For iteration number 2, so let me rub my screen first. It will be iteration number 2. Iteration number 2. For the second iteration, my search domain is, now my x1 will be x3. Okay, I will write search domain becomes my new search domain is, my search domain is from x3 to x2. x3, I will write it here, from x3 to x2. That is, in iteration 2, I will say my x3 is x1 and x2 is x2. Okay, my x2 is x2 and x1 is equal to x3, that's equal to 1.75, and our x2 is equal to how much? Our x2 is equal to 2. Therefore, the next search interval or search domain is equal interval from 1.75 to 2. Okay, our x1 is equal to 1.75 and x2 is equal to 2. Okay, now I will find again f of x1. So, okay, that's already done. I will find now the x3. Let's find the value of x3 for the iteration 2. For iteration 2, the value of x3 is x1 plus x2 divided by 2. That's equal 1.75 plus 2 divided by 2. Okay, and that's equal, once we calculate it, that is 1.875. This is the value of x3 for iteration 2. Let me rub it here. Let's rub it off. What I will get now is f of x3. I will obtain f of x3. That's equal f of 1.875. Okay, so I have to substitute 1.875 in this equation. That's equal 1.875 cube minus 1.875 minus 4. That's equal 1.875 minus 1.875 cube minus 1.875. That comes out equal to is it 1.875? F of this is 1.875. So it comes out equal to 0.7167. It comes equal 0.7167. This is f of x3. Okay, for second iteration. So what has happened? I will redraw my assumed graph. I will redraw this as an assumed graph. Say, for example, this is x2 because f of x2 is positive. This is 2. And I had x1 equal to 1.75 and f of 1.75 was negative. Okay, f of 1.75 is negative. Now I have got the third value, 1.875, such that I have got the third value, x3, as 1.875. It's in such a way that f of 1.875 is positive because this is positive. When f of 1.875 is positive, it means this x3 lies somewhere here. This x3 is here. This is 1.875 because f of 1.875 is positive. It can only be, this is your solution point, which we have to find. This is our xs. Okay, this is our x1. Fine. So this is my x1. This is x solution, which I have to find. This is x3 that I am obtaining now. Fine. So what will be the next search domain? Okay. So you look, your f of x1 is positive. No, sorry, negative. Your f of x2 is positive. This was the initial search domain. Now we got x3, okay, such that f of x3 is positive. Now what you have to do? You have to replace, I have been repeatedly saying that you have to replace your search domain with a new search domain, okay? Since this positive, again, this value of x3, this value of f of x3, that is this value of f of x3, is to be replaced now. Okay, this value of f of x3 will be replaced. I don't need now this value because this x2 has somewhere very close to this x's. Now I will take this value of the search domain. Okay, so in the previous case you had this value of x3. In this iteration 1, this was x3. So we replaced this with this because this is very, very close to our x solution point. Okay, now in this iteration 2, we have to make a choice between this value and this value. Since this is far away, we'll replace this. We'll take this to be our next search domain. So our next search values will be from this value of x to this value of x. That is, let me rub it here, for iteration 3. For iteration 3, I will write, for iteration 3, okay, my search replacement will become, I have to select, I have x3 and x2. My search interval is from x3 is here, okay, and this was my x1, okay. My x1 will remain as it was, so x1 to x3, okay. That is, let me not confuse students. What I will do, I have to replace my new search interval. I have to replace my new search interval. So my new search domain will be from, in my new search domain, I will have x1. I have not changed this. This is negative. X1 will be 1.75. And x3 will be equal to x2. That is In the iteration 3, x2 will be equal this value of x3, that is 1.875. Okay, so this is my iteration 3 will become at this value of x1 and x3, because I started with this 1.5 value and 2 value. Now 1.5 value was replaced by 1.75 value, and 2 value x is equal to 2 is replaced by 1.875. So look, x1 is coming close to xx as well. X2 is also coming close to xs. Fine. Now let me again do the iterations. Let me go ahead with the iteration third. So as we go ahead with the iteration third, it's now easy for us. We have to do it repetitively. So my third iteration will be f of x3. That is draw my x3 will be x1 plus x2 divided by 2. That's equal 1.75 plus 1.875 divided by 2. This is the new value of x3. Okay, and the value of x3 becomes equal to 1.8125. Fine, this is the x3. Now what I have to find, f of x3, as I am doing. So f of x3 is equal 1 point, that is substituting x3 back in this equation. Okay, that is 1.8125 cube minus 1.8125 minus 4. Fine, and that comes out equal to, f of x3 comes out equal 0.1418. This is the value of f of x3. Now again, I will repeat my graph. Let me repeat the graph. I had started with two values of x. x1 was 1.75, and x2 is equal to 1.875. That is some point here, 1.875. And in between two values, I am getting the third value of f of x3 such that the value, I'm getting the value of x3 such that f of x3 is positive. So it means it will be somewhere here. x3 will be here. That is this value is 1.8125 will be here, because at fx is equal to 1.8125, my f of x is positive. Okay, so now this at x3 my f of x is positive, at x2 my f of x is positive. So I will replace in the next search domain, I will have to replace this value by this value of x by this value of x. The reason is simple, because this value is very, very close to this solution point. So my new search domain will have same value of x1. So x1 will be equal to 1.75, but now my x2 will be 1.8125. Okay, so I will begin my next iteration, that is iteration 4. So I will begin my iteration 4. So now we will have iteration number 4. In my iteration number 4, the value of x1 is equal 1.75 and the value of x2 is equal 1.8125. Fine. Now I will find the value of x3. x3 is x1 plus x2 divided by 2. That will be equal 1.75 plus 1.8125 divided by 2. Fine. So that will come out equal. For iteration 4, the value of x3 will be equal. The value of x3 for iteration 4 will be equal 1.7812. It's 1.7812. Fine. Now I will find the value of f of x3. Let's find the value of f of x3. How I'll find the value of f of x3. F of x3 is 1.7812 cube minus 1.7812 minus 4, and that comes out equal to minus 0.1295. Okay, I will replot my imaginary graph or arbitrarily drawn graph. Okay, so my x1 was 1.75, at which my function was x1 was 1.75, and my x2 was equal 1.8125. Now I'm getting the third value of, I'm getting the third x3 value such that my function is negative. So it means x3 is here and the value of the function is negative. So for the next iteration, I will replace this by this, okay? Because this value is closer to my solution value. So what I will write, for the next iteration, my x1 will be this, that is x3, which is 1.7812, and my x2 is same, x2 is equal 1.8125. Okay, so with these two values of x1 and x2, I will begin my iteration 5. Okay, so what we will do, we'll begin our iteration 5. So for iteration 5, our x1 is 1.7812 and our x2 is equal 1.8125. Now what I am doing, I'm leaving from here as an exercise to the students, because this is, you have to repeat it. Okay, so what you will do, you have to do the repetition of the steps already learned. You will find the value of x3, that is x1 plus x2 divided by 2. That will be your x3. So 1.7812 plus 1.8125 divided by 2, that will be your x3. Okay, so x3 comes out equal 1.7968. 1.7968. Once you have calculated the value of x3, what you have to do, you have to calculate the value of f of x3. Repeat these steps. So what you will be doing, calculating f of x3 and see whether f of x3 is positive or negative. That is 1.7968 cube minus 1.7968 minus 4, and that comes out equal to 0.0046. This much, and this is positive. Okay, so you will again draw the imaginary graph, sorry, the arbitrarily drawn graph. You will again repeat it. Okay, so once you draw the graph, then arbitrarily drawn graph, once you arbitrarily drawn graph, you will write, for the next iteration, your f of x3 is positive, your x1, f of x1 is, f of your graph, arbitrarily drawn graph is like this. You are starting with x1 equal to 1.7812 and your x2 is 1.8125. Now you have got the third value of x, that is x3, at which your function is positive. So it will be somewhere here. Okay, this will be your x3. Fine. So you will replace this with this for the next iteration. That is x1 is equal to 1.7812 and x2 is equal to 1.8125. Then you will go to the sixth iteration. You will go to the sixth iteration. Okay, so go to the sixth iteration, repeat these steps again, find the value of f of x3, fine, keep on iterating, go to the iteration 6, 7. The number of iterations that you should go are around 9. Okay, this is iteration 6. You have to go to iteration 7, iteration 8, and iteration 9. Okay, go to iteration 9. Repeat these steps as soon as you complete iteration 9. Once you calculate iteration 9, stop. Okay, then what we have to do after iteration 9, I will be discussing in the next class. And in the next class, we'll finish this bisection method. But I want students to complete this task up to iteration 9. Thank you very much.